Similarly to how I went over Criterion A and B, just to show you how you can tackle the section, and then also go over some exemplars to show you how some students have approached this criterion and what's expected from the IB. So the first part, if we look through the technology template that I've given you, is approximately 2 pages, and that's the list of materials and manufacturing techniques. And this is pretty simple. The way I recommend that you do it is in the form of a table. So where you have your material and component, your description of that material and component, and then a justification of why you want to use that material or component, and then same for manufacturing technique. It is a picture, a description, and then a justification. Just to show you, let's look at some examples. These are from ISK students. So this is a reminder. This is Isaiah's from last year. This is his presentation drawing. He did a toilet seat for camping that you would put outside, and it's got a light integrated. Anyway, here he's got his materials, and again, I think it's quite nice to show a photo as well. He needs a toilet seat that he's actually getting off the shelf. He's mild steel. A description of what it is, more detailed in terms of like the sizes and all that sort of stuff, and then justification of why he's choosing this specific thing. So, for example, pop rivets, the thing is cheap, can join different materials, certain things, resistance to corrosion, etc. So he's justifying why that's the appropriate material. Similarly, we look at Amani's over here. Again, this is presentation drawing from Criterion B, and we go down. He's gonna let's see, explode isometric. He's done. So he hasn't done a faux. This is bill of materials. He's arranged things slightly differently, unless I missed. Let's look and see. Maybe I missed his material list. It must be earlier. Sorry about that. Where is his stuff? This is all Criterion B. Yeah, this is all Criterion B. Or no, this is Criterion. Sorry about that. He's got his final product. Looked like this is his joining. He's evaluating his design. So this is all B. This is presentation drawing, and then here he's got his material. So he hasn't put a photo, but he has material. Presented slightly differently. He said where that material is going to go. So he said so this, you need a steel rod, and it's going to go on the side of the box, and then the price, and then quantity, and then he's justifying it why this is good. So it's a similar sort of setup, but slightly differently arranged. That's fine. But again, I think however you do it, just make sure you have your list of materials. You describe where on your product those materials are going to be, and then you justify why that's a suitable material for your product. I'm actually going to quickly look at one of the IB examples just so we can look how that looks like. This was a seat for people. This is his presentation drawing from Criterion B. And then the way they did it is very different. They have, I don't actually see the way they've done it here, but let's just see. There must be another one over here. Let's look at that. So they have, yeah, similarly, you have your material. This looks like it's going to be a 3D printed thing. And then manufacturing technique, table saw, angle saw, so different things. Yeah, so different ways of doing it, but basically, I mean, however you want to do it is up to you, but I would recommend just a simple method. One thing that I have noticed that if your product is like, it only uses like 1 or 2 materials, let's just say you're 3D printing it primarily, you might actually add a couple of other materials that are not you're not going to use, but just to show that you're evaluating it. So for example, you might say PLA, ABS, PP are different possible plastics that you can use for 3D printing, and then you would just justify why, let's say, ABS is the one that you would choose for your product. And that's just it's just sort of making sure that you cover all the bases. Okay, moving on. So that's only about 2 pages. The next thing is the design proposal, and this is really the crux of this whole section. It's 9 pages long, is what they recommend. And here, what they want to see is basically all the drawings needed for somebody to replicate your product. So these are all the technical drawings. And what we want to see is an exploded isometric. So again, a drawing that shows how something comes apart and how it can be assembled again. Sometimes you can do an exploded isometric and an assembly drawing as two separate things, depending what your product is. Sometimes you can combine them, so you could sort of have it exploded, but also at the same time show how it's assembled. And then orthographic drawing, which lists all the materials and the components. So basically, again, this is a 2D planar view of your product. I'm showing all the different angles and how, and more specifically, the exact measurements. And then just a note that all the relevant measurements and annotations need to be on there. And the last thing is a bill of materials. So all this takes up the 9 pages. If we look at some of these examples that I showed you earlier, let's start with this is Amani's example. So he's got, so we talked about that, he's got his manufacturing techniques, and then over here he's got, this is his exploded isometric drawing. So he's exploding it, and he's sort of explaining what all the different components are. And I think in his case, this doubles as an assembly drawing as well. Then he's got his technical drawings, and you can see that like this is that agitator rod, and he's showing exactly the different measurements, how it looks like from the front. The one thing he hasn't labeled, which I would change, is he's got, like, this should say, to make clear what we're looking at. I mean, I can kind of see what we're looking at, but he should have said, like, front, side view, just so that's clear what view we're looking at. But you can see what he's done. So every single component is taken apart, and he hasn't labeled it. Again, he should have done that, but again, all the measurements are there to see how it's put together. These are the panels that slot in, and again, all the measurements, and you can see it's not hard to see how it can take up 9 pages, because every component is, and again, this is quite easy to generate from Fusion 360 if you go into the drawing mode. Cool. That's Amani's. If we go, let's look what else we had here. We had this was the toilet seat example. This was Isaiah's. So if we go down from his, this is his his production methods here. And then so he's got, this is sort of, I guess, a general isometric drawing. This is now his orthographic drawings. So he's got the side view. He probably has just at some point he'll have just he's got electrics in there, so he's got an electrical schematic of how that's going to work and function. This is the stand, the top base, top seat. How this is an exploded view, how it all comes in together. Okay, so those are his technical drawings. Let's look at some of the IB examples quickly. I shouldn't have closed that because that's, we'll look at those later, but let's just see. This is that seat again that we talked about. So he's done in a similar way. You can see he has an isometric version of it, and then he sort of explains what he's looking at orthographically here. That's fine too. Again, but you get the idea, all the different angles, all the different sides, and how it slots together. This is his assembly drawing, and then he's got a bill of materials with the costing over here of each of them. Cool. And I would, and there's different ways you can do this. You can either have a separate bill of materials. Some people have done that, or you can just add combine it all and add the bill of materials into the list of materials and components as well. That's kind of the way Amani did it earlier. He didn't have it separately, but he just had it all into one big table. I would probably do it separately, but it's up to you. Okay, cool. So that's that. And then the last part is pretty simple, and it's a 2 pages, and it's a plan of manufacturing. And all you're expected to do is create a table like this, where you have your processes, equipment, scheduling, quality control, and risk assessment. And it's basically a timeline of how you create your product, or what you need to do to create your product. They give you this template, so there's no way to deviate from this table. It's what they want. So again, if we look at, I closed some of these windows, but if we look at, let's say this one here, this was that ergonomic seat, you'll see, you can look at these examples and see you have the process, the equipment, scheduling, how long it takes, 30 minutes for marking out these parts, quality control, how you're going to make sure that you're doing it correctly. So like if you're cutting, you're going to ensure blade is sharp and straight and accurate to cut veneer. So it's pretty like detailed about how you're going to, and then risk, what's the possible risk here? So PP, personal protective equipment, you need some extraction system, I guess, if you're sanding, in this case, sanding stuff, so to get rid of the sawdust and stuff. So, and again, what's quite, and I quite like this, so instead of making it like a lot of your products are going to have, different components. You might, assemble something first and assemble the second thing, or one thing slots into another thing. So just, it's still the same table, but just separating it into like, different subtables. So this is the first part you got to do, then this part, this part. This doesn't go into your word count at all. So this is kind of a nice thing because you can just basically, the only thing that's important is actually, it does go into your word count, but as it's all in a table and none of these cells can be more than 10 words. So it's the reason they do that is just to encourage you to basically really dissect what you're doing. So you wouldn't say, I'm going to sand and saw off this piece. No, you would say, I'm going to sand it, one cell. I'm going to saw it, one cell. I'm going to remove the things at the other cell. If you look at some of the examples that use 3D printers, you would even say, you might go as much detail as like, turning on your 3D printer, leveling the build plate, inserting the filament. So like really, the more detail, the better in a way. That's that. And then the last thing that some people have done, and I would encourage you, it's not a hard thing to add, is a Gantt chart at the very end. So if we look at this, so once you have this is like a very detailed, almost I would say like, excessively detailed step-by-step process of creating your product. And the Gantt chart is just a visual representation of what you've done. Let's see if I can find some examples that, not a visual representation. So this is another example. This is a table that somebody created, so you can see these are all his technical drawings, and this is his parts list over here. That's fine. And here's his production plan, so he's broken it up as well. You can see into all the different components of how to make it, and then he's got a small Gantt chart at the end, so you can see that this is kind of the same thing. This is how to make it step by step. So first do this, then do this, then do this, step 1 by 1, 2, and I'm guessing he has these different parts that then get assembled together. But then this is kind of a, you can kind of see each box equals 5 minutes. This is roughly how much it would take. This is how much it would take, and this is, so it's just a visual representation of that. And then that's it for Criterion C, and you're done.